Hello friends, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created a bunch of playlists to cover various categories of problems such as BFS, DFS, stacks, queues, dynamic programming, and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from description below this video. Let's jump into today's problem. Maximum value after insertion. You are given a very large integer and represented as a string, and an integer digit x. The digit n, and digit x are in the inclusive range 1 to 9 and may represent a negative number. So the inputs are 2, n and x. N is in the string format. N is a very large integer, but it is given in a string format. X is a single digit basically, and all the digits in the number and x are in the range of 1 and 9. So, and the number could be, that means n could be a negative number also, right? So, and now you want to maximize n's numerical value by inserting x anywhere in the decimal representation of n. You cannot insert x to the left of negative sign. So that actually makes sense, right? So if you insert into the left of the negative sign, it cannot be called as a number. So you have to insert between the digits. It could be after the negative sign also, right? So that means that's what it is. And we are supposed to return a string representing the maximum value of n after the insertion. So that's the problem statement, right? So let's take a couple of examples and try to understand what it is actually. So if number is a positive number, as we know, there are two different kind of numbers, right? So the number may represent a negative number, and it could be positive number also. So let's look at the positive case first. So if the number n is 73, as given as a string, as it said, right? N represented as a string, and x is equal to 6. This is a single digit, right? So if that is the case, right? So how many places the 6 could be inserted, right? So I have a little formula here. If the number is positive, right, and we are calling length of n is L, then we have L plus 1 number of positions that we can insert in, right? The x, right? So if the number is up length 2 digits, then you can have 3 inserting positions. So 6 can be inserted at the first position, I mean before 7, and 6 can be inserted after 7, 6 can be inserted after 3. So that means 3 positions. So likewise, these are the outputs after inserting, right? If you insert before 7, it will be 673. After 7, it will be 763. After 3, it will be 736. But out of all these three things, right, what is the maximum that we need to give in? Because we are supposed to return the maximum value, right? So 763 is the maximum, right? Similarly. So let's take another example, 3, 4, 6, 2. And if you insert 5, these are the 5 examples. And the maximum value is the first one. And if x is equal to 1, for the same thing, for 3, 4, 6, 2, if x is equal to 1, if you insert 3, 4, 6, 2, 1 is the maximum number, right? So that's how the numbers that we have to come up with. But from these numbers, right, let's identify a little logic, right? So when we, what is the actual position that we will be inserting x is the question, right? So that's what it is. So the logic is find first number c such that x is greater than c, right? So this is the logic. Find first number c such that x is greater than c. What is c is representing? C is representing each digit in the number n, right? So find the first number c such that x is greater than c. So let's apply this logic and see where we are going to insert, right? So 6, right? X is 6. So 6 should be greater than the number c. So is 6 greater than 7? No. Is 6 greater than 3? Yes. So this is where, that means in the position of 3, we need to insert. So after 7, units, if you insert 6, that will be our number, 763. So that's what the answer is, right? So this is essentially the logic that we need to implement. Let's see for another thing. So x is equal to 1. This will be an interesting case, right? So here what happens is, let's copy this number because we are trying to get that number basically, right? So this is what. So find c such that x is greater than c. So 1. Is 1 greater than 3? No. Is 1 is greater than 4? No. And was 1 greater than 6? No. Is 1 greater than 2? No. So we have exhausted all the numbers, right? So in that case, where you are going to append x? Obviously at the end of the entire number. So that's what we are appending. We got 3, 4, 6 to 1. Obviously that will be the maximum number after insertion. So that's how, I mean, that's a special case. Everything else is fine. So there are two cases. One is x is greater than c, right? So you will be inserting that the replacement index, but otherwise you will insert at the end. So this is for the positive case, positive numbers case. But what if the number is negative? So if the number is negative, the zeroth index in n will have a negative sign, right? So we will just look at the same example. Number is negative 73. So that means zeroth index will have a negative sign. And that means we will have the digits starting from index number 1. So in this case, how many positions that we can really insert, right? So if the number is negative number, I have another formula here. So what we are essentially doing is the length of n, we are calculating that and subtracting 1 from it. Why? Because we cannot insert before negative number and negative sign. So all we can insert is these two, right? Before 7, after 7, and after 3. That's it. So that's why we will say, okay, this is what it is. Length of n minus 1 is the 1. So obviously L plus 1. So whatever the length that you calculate. So when the when the number is negative, you are removing the sign and minus 1 for the sign. When if it is positive, just take that whole length and add a 1. That's it. So that's what it is going to, right? So minus 73. As we said, 6 could be inserted before 7. That is 6 minus 673. 6 could be inserted after 7. Minus 763. 6 could be inserted after 3. Minus 736. So out of all these, right, what is the maximum number? It is minus 673, right? So that's what the answer that we need to give. Let's look at another example. Minus 55, x is equal to 2. So if as simple as this, right? So you could insert 2 before 5, after 5, and after the second 5. So if you insert like that, right? So these are the three numbers that we will be generating. And out of all this, what is the maximum number? Negative 255. This is what we want to return. So if we closely observe, right, what we are essentially doing is we are trying to find first number c such that x is less than c. X is less than c. 2 is less than c. C is each digit in the number n. So that's what it is. So essentially, we are going to implement these two logics for positive and negative numbers respectively. Let's go and look at the code in order to understand it in a better fashion, right? So, and first thing is we are going to assume the input is valid. That means there are no negative signs and there are no multiple negative signs and there are no decimal points, all that stuff. So we are assuming the input is valid. Otherwise, what we will write is a validate input kind of method, so which will validate for all that stuff, right? But in this case, we are just blindly assuming that input is valid, right? And I'm declaring a local variable replacement index as -1. So first case, I'm going to tackle the negative numbers, right? And for I in the range of 1 to length of n, right? Why we are going starting from 1? Because 0th index in a negative number is minus sign, right? That's why we are starting from index 1. Okay. We are just putting this in a little variable here, right? And if x is less than ordinal of c minus ordinal of order of 0. So why I'm doing this is because the representation of n is a string. I want to really get the value of the particular character at particular index, right? So that's why I'm doing ordinal of c minus ordinal of 0. So this will give me the actual value, actual digit. So I'm comparing the x is less than that digit or not. If it is so, then we got the repetition index and you just break it up from there. All we need is just first replacement. We know where we want to replace repetition index. But in the case of positive number, right, all we're going to change is the logic in the for loop. So we are going from 0 to len of n. So 0 is optional. So that's why we are going len of n. In the positive case, we will be starting from index 1, but in the negative case, we will be starting from index 0. So that's the change here. And the other change is if x is greater than c. That's what we said, right? If x is greater than c, we found the replacement index and then breakout. So as and when actually this repetition index is not necessary, we can take it off because we have already declared here. Good. And if repetition index is equal to -1, that means we have not found. So if you recall, this is the case 3462, right? That's the case 3462. That means we are supposed to insert the x at the end of it, right? That's what we are doing. We are inserting x at the end of it and returning it. Otherwise, what we are doing is we are splitting. So we are going to get the first part until repetition index and put x in between and put the rest of the stuff from the end. That will be the result, right? So just to recap, right? So the basic thing is as long as your is less x is less than c, you skip those numbers, right? As long as x is less than c, you skip those numbers. So x is x6, 6 is less than 7, right? Skip it. But 6 is less than 3, no. That is where you need to insert. That is the simple logic here. I wrote it in a different way. Basically, you are trying to find the first number such that x is greater than c. So that's how it is. And for the negative numbers, it's quite opposite of it, right? So that's the crux of the algorithm. And let's go ahead and look at the time and space complexity, right? Time complexity. We are saying time complexity, the total time that we are running here is, in this particular case, we are going to exhaust the given number, right? So that means length of n. So we will be going through the length of n. How many of our characters that are given in the n, we will be exhausting them. So that's why time complexity is order of length of n. And what is the space complexity? Are we really using any space here? Yes, we are using rep index. And are we using any other space? We are not explicitly using the space here. We did not declare, but we are using it to return this, not this, basically, right? Because this will create a new string when you append, when you join two strings. So for that purpose, we need to account the space, right? So what we are doing is length of n is length, and we have one character, right? So length of n plus 1. But when we actually give the big O notation, right, we will knock off ones. That's why we are saying the total space complexity is order of length of n. That's it. That is as simple as that. So time complexity is order of length of n, and space complexity is also order of n. Hope you understood the problem. If you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I posted the code on the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to the channel, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem soon. Till then, stay safe and goodbye. Thank you.